Absolute value inequalities. We're going to deal with two forms of the absolute value inequality, and that is the first degree polynomial inside the absolute value and a constant outside, or a first degree inside and a first degree outside. Let's look at the first type. This is going to be treating it in a slightly informal fashion, and not the absolutely formal fashion. The formal one strictly sticks to the definition of absolute value. If anybody needs that, just message me in YouTube on this video, and I will put up a video with the more formal way to do it. Now, when we have a look at that, let's have a look. There's a simple form of this type here, either or equal to or just less than. Now, that means we have x, negative x, as per definition. There, though, have a look at this, the word and. The words and or are very important in inequalities. And means that x has to satisfy both conditions, or however many there are, or means x need only satisfy one of the conditions to be acceptable. This implies an overlap of regions. If I take that one step further, you see there we are, we've taken x to greater than negative 3. Notice the sign has switched now because we've changed signs, and we can simplify it to there. Now there you can see it's a single region, it's an overlap. X greater than negative 3, x less than 3. So it's wherever x satisfies both those conditions. And that's for the and. This can even be written separately. It could be written as x is greater than or equal to negative 3 and x is less than or equal to 3. We could write 2, but we'd have to have the word and. Let's look at an example. This means x plus 6 is between negative 5 and 5. There are three components to this inequality, and I need to get rid of the 6 by subtracting, so I must subtract 6. And there's the answer. Let's now look at the greater than or equal to. Once again, by definition, x, negative x, but notice there's an or now. If you look at this one here, where it's less than, one could reason that it has to be in a single region. X cannot be 5 because that's too big. X cannot be negative 5 because absolute value will make a positive 5, and it's also too big then. So x must be between negative 3 and 3. So these are not too bad to reason. This one here, x greater than or equal to 3, well, if x is big enough, then it'll be bigger than 3, or if x is small enough, what I mean by that is negative numbers, such as negative 5, it will also satisfy that. So bigger than 3 or less than negative 3, but not and. There we are. I've written that one first with the switch and signs, and that one second, just to put the smaller one first. Let's have a look at an example. That means we have the two extremes because the absolute value is greater than or equal to 10. So therefore, the absolute value, the contents of the absolute value, 3a minus 5, less than or equal to negative 10. It carries the or equal to with it. Or 3a minus 5, greater than or equal to positive 10. Now those are two separate inequalities which we are going to solve. And that's the answer. They don't overlap. They are separate regions. This one here is just to remind you that negative k there is going to be an extra problem later. So there's no harm in writing k minus 1 inside. Because remember, absolute value of 1 minus k is the same as the absolute value of k minus 1. Useful move with greater thans or less than, with them swapping around and everything else. So this one means it's going to be on the extreme. So therefore, less than negative 5, greater than 5, or equal to. Solve, and there are answers. Watch out for some of these ones where you can save time or not make errors. If you have a look there, this says this absolute value, 3 times it, same thing, must be greater than -1. Well, absolute values are positive. 3 times an absolute value is positive, or 0, but nothing else. So that's true for all elements of real numbers. X is an element of real. Now we look at the opposite, where that absolute value less than -1 cannot happen. This is positive. You cannot get it less than -1, so therefore no solution. This one, we'd also be tempted to say no solution, absolute value negative, but that equals 0 we must keep a watch out for, because that is still possible. So therefore, this inequality is turned into an equation, which we then solve, etc. Let's have a look at some examples. You try them, pause, try them, before we go through them. But the first one, greater than, so it's on the extremes, except that we'll notice, hang on, absolute value greater than -5. Oh no, that's all real numbers. I kept my eyes peeled on that one. This one here, how does that compare to that one? Have a look. In fact, it's exactly the same one, because we can write 3 minus 2x is 2x minus 3 within the absolute value. So again, x element of reals. This one, absolute value less than 1, well, that means a single region and it's between the -1 and 1. Subtract 7 3 times, divide by 3 3 times. So there we are, we've subtracted 7 and we divide by 3, and there's our answers. This next one here, we need to get that absolute value on its own. Being a negative outside, I'm going to take it to the right and bring the 3 to the left. There we are. But my upbringing keeps making me want to put the variables on the left of equations and inequalities, so I'm going to switch it around. But notice that this sign will switch with it. So this has gone there, the 20 has gone there, but have a look there. Because you see, the absolute value is greater. If we read from that side, absolute value is greater. Now greater means the extremes, therefore we have it less than or equal to -20 or greater than or equal to 20. Two separate inequalities to solve, they're the answers. The one or the other. Next one, there we are. And now 2a minus 5 is going to be between the two extremes. -9 less than or equal to 2a minus 5 less than or equal to 9. Get rid of the 5, add, get rid of the 2, divide, divide, divide. So there's got rid of the 5 by adding 5 to all three, dividing all three by 2. Let's look at the next type, the other type of inequality. We're going to treat this in much the same way, but as with equations, it's becoming very important you check your answers. Very important you do check your answers. So let's look at the first case. So what we're going to do is we're going to treat this as the number. So we're going to see this as a number, absolute value less than, which means the absolute value is between the negative of this and the positive of it. There we are. Simplify. Oh dear. Yes, we have a problem. It's easy enough to get rid of the 3. We just add 3, add 3, add 3. But to get rid of these x's here is a serious problem. If there's a positive x, that's easy because then we just subtract x on all three. But if I add x to get rid of it there, this is going to become 2x. If I subtract x there, this is going to become negative 2x. So in fact, we're stuck going around in circles, catch 22. But we can go back to what it means. And you may remember that I said, if you take this inequality like that, a single region, we can write it as 2. X greater than or equal to A and x less than or equal to B. There we are. Now that's exactly what we're going to do there. We're going to say this is less than or equal to that, and that is less than or equal to that. So therefore, we're going to take that as an inequality. We're going to have an and, because that's what it means, and we're going to take that one as the inequality. Now let's solve them separately, remembering that we have an and. So now I'm going to go to a number line. There's my number line. There's the -2. There's the 12. There we are, less than 12. Greater than -2. It's and, so we have to say x must belong to both. Where do they overlap? Here we are. So that is our answer. We are going to test now. We're going to test less than -2, between the two, and after. We will test all three areas. We always do, because these have a funny habit of biting you in the foot just when you think that you've finished. There we are. I've said e.g. because what I'm going to do is that's -2, so I'm going to test -3 in the beginning. I'm going to test 0, which is definitely between them in the beginning. I'll always use 0 if I can. And 13 I'm going to test to see in that original inequality. And in fact, there we are. Does not work, does work, does not work. Yes, so we are in the right region. Those are excluded by checking as well. So there's our answer. Let's have a look at another example. Now we have a greater than or equal to. Move the 21 to the other side. Now we have the two possibilities. The contents is less than or equal to the negative of that, or the contents greater than or equal to the positive of that. There we are. Solve two separate inequalities. There's the answer. I'm doing a bit of a poetic or mathematician's license by going straight to the answer. Now if we draw up our number line, we're going to end up with, if we check, I didn't draw up a number line. I don't even have to actually. X less than 2, x less than 24. No, it means x less than 24. But I'm going to check. Less than 24, for example, 20. I substitute in there to make sure. Then I'm going to try greater than 24, like 30, and substitute in there. Definitely seems to work okay. So therefore, in fact, we know that that is our answer. Let's have a look at another example. Alright, now less than or equal to, so it's between. It's between the negative of that and the positive of that. There's 3x minus 6's. So there we are. We've ended up with the same situation as before, where we're going to have to split that because we've got a negative x and an x. Never shall we get rid of them by the traditional means. We separate, have that as an inequality, and then this as an inequality. There we are. Solve the two of them, and we end up with those two answers. X greater than or equal to 2 and x less than or equal to 2. Well, yes, if I check, this implies x can only equal 2. So I've checked less than 2, greater than 2. I've just checked to see. I've checked 2 itself to make sure, and it works. Therefore, there's the answer. Very funny things you come out with these inequalities. Let's do another one. Right, now, I've taken that to this side so it is a positive absolute value sign. I've done the turnaround. No, I haven't. I've multiplied through by 2 to get rid of the fraction. Now I've done a turnaround. where that turned with it, notice, because I like to have it on this side. Greater than, so it's now the extremes. Twice that, this is still a bracket, remember, twice that is less than the negative, or twice that is greater than the positive. Solve, and we end up with x less than 4 or x greater than 2 2/3. There we are by number line. Less than 4, there it is there, or greater than 2 2/3. Now it's an or, it's not an and, so don't go taking this region here. It's the one or the other. So in fact, all three regions work. Take a value less than less than 2 2/3, such as 0, it works. Take a value between the two, such as 3, it works. Take a value after 4, such as 5, it works. Even though it's excluded for 2 2/3 there, because it's greater than, it is included by the less than 4. Therefore, what do we get? X element of reals. Some examples to try. Pause, try them first. Right, looking at the first one here, less than or equal to, so means 2x plus 5 is between the extremes. There we are. We have to separate it into two separate inequalities, that inequality and that inequality. With an and, because it is and. Solving, we get those two values. There we are. Let's show it on the number line and we check. Just showing you the checking on the number line. Before negative 3.5, like negative 4, substitute try. Try between the two, such as negative 1, try, yes, and try afterwards, such as 1, and we found it didn't work. Therefore, that is our answer. Next one. I moved one to the other side. Greater than, so it's the extremes, which means 3x minus 1 is less than the negative, 3x minus 1 is greater than the positive. Simplifying, solving, we get that. Once again, mathematician's license, I've gone straight to the answer. That's what we have. So we can have it there, or we can have it there. And it's an or. We don't need an overlap. Overlap, in fact, would mean all of them. But, so one or the other, so therefore that's acceptable as our answer. Next one. Taken 2x to the other side. Greater than or equal to, so therefore it's extremes. There we are. X minus 3 less than or equal to the negative, x minus 3 greater than or equal to the positive. Solving, we end up with x less than or equal to 3 or x less than or equal to 3. Well, that's pretty obvious, but let's draw up our number line so we can check. Yes, there we are. We check numbers. That's 3. I tried 0. Always try 0 is so much the easiest number to substitute. Next comes 1. But I can't use 1, so I'll have to use 4. When I substituted 4, it was not true, so therefore the cross, true at 3. Just in case I tried that. Therefore x less than or equal to 3. There's our answer. Next one. I'm going to move the absolute value to the other side. Oh, I moved it to the other side and switched it around. I'm getting out of hand with my mathematical license here. Notice, goes to that side, reads absolute value less than that, and I've turned it around. This is now less than, so it's between the extremes. Now once again, I'm not going to be able to eliminate, so I have to separate into two separate inequalities and solve each. And we get that as an answer, x greater than 1 and x less than 2. There we are. That's fine. I should really have written that back as 1 is less than x is less than 2. That's fine as an answer. But yes, how remiss of me. Right, let's have a look at the next one. Less than or equal to, so 3x minus 6 is between the extremes, the negative and the positive. Separate it into two inequalities. Solve the two inequalities, x greater than or equal to 2 and x less than or equal to 2. Notice the dotted lines. Because you see, x greater than or equal to 2 is there, but it has to be this at the same time, which isn't. So it's not included there. We checked and there we are, and it's okay there. So there we are. X equals 2.